as we now know, you need to find how many faces, you need to calculate the areas of those faces, and you need to add them all together. For the cuboids, uh, we know that we have the height, the length, and the width. Then how many faces do we have in this cuboid? It will be 6. Then we add together the areas of all 6 faces. You calculate them and add them all together. Let's see this in practice. For this cuboid or rectangular prism, you have 6 faces as we've just seen. This will be the top face and the bottom face, and there'll be the front one and the back one that side, and then there'll be this one on the right, and then there'll be that one on the left. So altogether 6 faces. Then the surface area, if we follow the 3 basic steps, which is determine how many faces are there, calculate the areas of those faces, and then add them all together. It's as simple as that. So let's look at the front one. This one here, it has that length and this height. We know we calculate that length by height. To that we add the back one, which is directly opposite that one. It's the same thing. And then we have the left one, calculate that area, and then the right one, calculate that area, and the top one and the bottom one, you add them all together, you get the surface area of the whole cuboid. That brings us to task number 3, which is worth 5 marks. So for this figure, you need to calculate the surface area. And the hint is start by figuring out how many faces this figure has. Measurements are given, and they are enough for you guys to calculate the surface areas, and all measurements are in centimeters. Cool. Then surface area of triangular prism. Again, now that we know how to calculate the area of a triangle, now we're talking about a triangular prism, which is a 3-dimensional object. So what do we do? Following the 3 steps, how many faces of a triangular prism are there? So you count how many faces, and then it will be 5. Then you calculate the areas of those faces, and then you add them all together. Seeing this in practice, where are the 5 faces? It will be the bottom one that we don't see, 1, the right one, 2, the back one, 3, the left one, 4, and the front one. That gives you 5 faces. Then you have to calculate the area of those, areas of those, and you get the surface area. So it would be the front one plus the back one plus the left one plus the right one plus the bottom one, and you get the surface area of the whole triangular prism. Here's another example. Find the surface area of the following prism. It's got 8 centimeters running down this way, 5 centimeters here, and then 6 centimeters on the base, and then 7 centimeters height. How do you go about that? Simple, follow the 3 steps that we mentioned. So we have this triangle, which is the front one here, and then the height of it is 7 centimeters, and it's the base 6 centimeters. There is 2 of this, because there's this one and there's the one at the back, the one opposite it. So you calculate the area of this triangle and then you multiply it by 2, you will have sorted out two faces of this prism. And using the formula, we know the formula for a triangle is half base times height. That works out using those measurements to half of 6 by 7, which is 21. Two of those because there are two faces. Gives you 42. Then, since we've sorted out the triangles, what is there again? There's this face here on the right here that runs this way. That's a rectangle or a rectangular face. It measures 8 centimeters and 5 centimeters. And it's easy now, we can calculate the area of this face by multiplying 8 by 5. But there's two of those because there's this one and an opposite it, which is this one on that side. And the area base times height, as we know for a rectangle, and then it is 40, but multiply by 2 because there's two of them, you get 80 centimeter cubed. Then we're done with this four sides, this side of a triangle and that side of a triangle, and then this one and then that one. We're done with the front, and then there's that one at the back, and then we've done the right and we've done the left. What is left is the bottom square, which is that one. And again, area of that given by 6 and a 5 centimeter, base times height. And for this one, you don't multiply by 2 because there's just that one. Then you finished. You're done calculating all the areas, then you add them all together to get the surface area, which is 152 centimeter cubed. So by definition, or a different definition, surface area is the total area of all faces. Here's another practical example. Surface area of cylinders. Where would you apply that? As designers, you might find yourself having to design labels for a can. This is where surface area knowledge comes into play, because you know now that you need to design a label and you need how much material to wrap around the can. Knowing surface area can help you identify that or work that out. So if you were to tear up this label from the top to bottom, it will stretch out to be like this, which is now a rectangle that you can calculate the area for. So what is the length of it? Because to calculate the area of the rectangle, you need the length by height or length by breadth. So what is the length of it? Length of it is the same as the distance around that top. Then what is the distance around the top? It is the circumference of a circle, given by what formula? Pi multiplied by diameter. Cool. So then, to get the height, because we know to calculate the area of a rectangle, we need the length and the height. The height then would be equal to from the top of a can to the bottom of a can works out to the height, which is abbreviated h. We are done. We can calculate the area of this rectangular shape, which is now our label. We know that pi diameter, its circumference, works out, it becomes our length, and then you multiply that by this, which means to get the area of this label is pi dh. surface area of just the curved part, which is this one, unwrapped to a rectangle, it will be given by pi dh. Pi dh. We are not done, because this is just to figure out a way to help us calculate the surface area of a cylinder, because now we know the curved part works out to pi dh. Cool, let's put that into practice. So when you calculate the surface area of a cylinder, you will have to calculate the area of the top circle, multiply that by 2 because it's same as this one, or work them out separately as the area of a circle. We know by formula it is pi radius squared. Here's another one, area of the bottom circle, pi radius squared. Then we just worked out how we can calculate the area of this curved part of the cylinder, which is pi dh. Put it all together into one formula to calculate the surface area of a cylinder. It becomes 2 multiplied by time radius squared, which means the top part and the bottom part area sorted out here, hence the 2. To that you add the area of the curved part, which is pi dh, and you're done. Let's put some numbers to it. If you have the diameter of the cylinder as 4 centimeters, my bad, and the height is 6 centimeters, that makes it easy. For the top part, we know that the area of a circle is pi radius squared, so which is pi multiplied by the radius, which is 2, radius of 4, which is diameter, is 2, then you square that works out to pi radius squared there, and then it gives you the answer. The curved part, we know now it's pi dh. Pi diameter is 4, h, which is height, is 6, gives you that. And then we go to the bottom circle, same as the first circle, pi radius squared, you get the answer. And then add them all together to get the surface area, or the total area of surface area of a cylinder. And then that's your answer. That brings us to task 4, which is worth 5 marks for each of this. So you're going to work out the surface area of these prisms, that one and this. So on the task 4 you have A and B, 5 marks each, 10 in total. Go. So in summary, surface area, in order to calculate it, normally we use what is called nets. You might bump into this when you're doing your additional reading to understand, or if you went through the documents that I uploaded for you already. So you use nets. What this means is you take a 3-dimensional object, you break it apart, or you unfold it into faces that it has to figure out how many faces it has. And we know, applying the 3 steps, after you figure out how many faces it has, you calculate the areas of those faces. Having done that, you add all the areas together and you get the total surface area, the total areas, which gives you the surface area. So the nets are usually used as a method of finding surface area of a geometrical figure by opening that 3-dimensional object up. This makes it easy for you guys to see all the faces which you need to calculate the areas for. So then, to conclude, surface area is important to you as designers because you are the makers of products. And then why is that important? Because it tells you the material, or how much of material is needed to make a product. That's where you would apply the knowledge of surface area. or how much of material is needed to apply onto an existing product. So try and think of this in that light. Then you will see the relevance of this to you as designers. Any products that you're going to make, you're going to use material. How much of material? You can use your knowledge of surface area to calculate that, to know how much you would need or how much you would need to apply onto an existing product. Hope this makes sense. That's the end of surface area. Cheers, guys.